Look at your hand. Now, look at a modern African elephant, the undisputed king of the land. At 6 tons, it's a living fortress. But if you were to stand an elephant next to the Argentinosaurus, that elephant would look like a golden retriever standing next to a semi-truck. The blue whale is the largest animal to ever live, but it has a cheat code, the buoyancy of the ocean. It doesn't have to fight gravity. But the dinosaurs? They walked. They ran. They fought. They existed on a scale that defies our modern understanding of biology. We are living in a world of miniatures, a world of small things. The mystery isn't just that they were big. The mystery is why the rules of reality, that keep a modern lion or a rhino at a manageable size, simply didn't seem to apply 100 million years ago. Why did the Earth once allow monsters to walk, and why won't it allow them back? To understand the giants, we first have to understand why you aren't 30 feet tall. It's called the square cube law. It is the fundamental speed limit of biology. If you double the height of an animal, you don't just double its weight. You triple its volume and weight, but the strength of its bones, the cross-sectional area, only squares. Essentially, if you grew 10 times larger right now, your bones would snap like dry twigs under the sheer pressure of your own meat. In our modern world, we see this limit everywhere. The African elephant is near the breaking point. If it gets much bigger, it can't move fast enough to escape a predator or find enough food to fuel its massive heart. We think of nature as having a ceiling. We see the fossilized remains of a Brachiosaurus, 5 stories tall, and our logic tells us it shouldn't be able to breathe, let alone walk. We assume the dinosaurs lived by our rules. We assume they were just big lizards. But a lizard the size of a house would overheat and die in hours. To reach those heights, the dinosaurs had to hack the system. They didn't just grow larger, they re-engineered what it meant to be a living, breathing machine. The first level of strangeness isn't in their size. It's in their weight. Or rather, the lack of it. If you picked up a bone from a sauropod, those iconic long-necked giants, you'd expect it to feel like solid granite. But it wasn't. It was more like a high-tech aeroframe. Their bones were pneumatized. They were filled with air sacs, just like modern birds. This bird tech allowed dinosaurs to have necks 40 feet long without their heads collapsing their own ribcages. Imagine trying to lift a solid iron pillar versus a hollow titanium tube. The tube is just as strong, but it's light enough to move. Then there's the engine. A mammal's lungs are like bellows. In and out, in and out. It's inefficient. But dinosaurs had a flow-through respiratory system. They were constantly pumping oxygen-rich air through their bodies, even when exhaling. This gave them the metabolic potential of a lightning bolt. They weren't sluggish. They were high-performance athletes in a body the size of a cathedral. They could grow so large because they were essentially hollowed-out balloons of muscle and air, fueled by a respiratory system that makes ours look like a steam engine in a Tesla world. They hacked the system. They didn't just grow larger. They re-engineered what it meant to be a living, breathing machine. Now, we go into the deep end. Because even with light bones and great lungs, you still have to eat. And the math of eating for a giant is terrifying. An Argentinosaurus needed to consume roughly 100,000 to 200,000 calories every single day. For context, that's about 400 Big Macs every hour, 24 hours a day. How do you eat that much? You stop chewing. Chewing is a waste of time. Mammals like us spend hours grinding food. Dinosaurs didn't. They evolved rake-like teeth. They would simply strip an entire tree of its needles and swallow them whole. Inside their bellies, they had gastroliths, stomach stones. They swallowed rocks to do the grinding for them. Their stomach was a literal cement mixer, churning 24/7. This created a massive amount of internal heat. This is where it gets creepy. They were so big that they became gigantothermic. They didn't need to be warm-blooded or cold-blooded. Their sheer mass acted as a thermal battery. They were so large that their body temperature almost never changed. They were living, walking climate-controlled environments. But there's a darker side to this adaptation, the life fast, die big strategy. Mammals take a long time to raise a few young. Dinosaurs? They laid hundreds of eggs. They were our strategists. They flooded the ecosystem with tiny, fast-growing babies. A hatchling Brachiosaurus was the size of a kitten. In 30 years, it would be 70 feet long. That is an explosive rate of growth that no mammal on Earth can match without its heart exploding. They survived because they were a paradox. They were built like birds, grew like weeds, and ate like machines that never turned off. But here, the data goes dark. We have the how, but we still struggle with the limit. Science has no definitive answer for why nature stopped. Why don't we see 30-ton elephants today? Some point to the oxygen levels of the Mesozoic, but recent data suggests oxygen wasn't actually that much higher than it is now. Others point to the carbon dioxide levels and the lushness of the flora, but even in our most fertile rainforests today, we don't see animals scaling up. There is a genetic ghost in the room. Was there a specific gene, a master switch for growth, that was flipped on in the Triassic and off after the asteroid hit? We don't know. We are looking at a lost blueprint. When the dinosaurs died, it seems nature threw away the instructions for building on a grand scale. We look at these giants as monsters, as mistakes that went extinct. But they were the most successful land animals to ever exist. They held the throne for 165 million years. Humans? We've been here for a fraction of a percent of that time. Understanding why they were so big reminds us that we are not the final form of life on Earth. We are just one variation. We live in a world of the small, the fast, and the intelligent. But the Earth remembers a time when the ground shook with every heartbeat, when the sky was filled with leathery wings the size of planes. The giants are gone, but their lesson remains: nature doesn't have a fixed scale. It only has the scale that the environment allows. And as our environment changes, who's to say what the next giant might look like? Maybe we aren't the end of the story. Maybe we're just the intermission.